Tachyons are theoretical particles that travel faster than light, challenging the very foundation of physics. These particles break the speed barrier, defying Einstein's theory of relativity. The idea of tachyons emerged from quantum field theory in the 1960s, when scientists like Gerald Feinberg theorized their existence. In quantum field theory, tachyons are hypothesized as fields of energy, influencing the structure of space-time. Tachyons gain mass as they move faster, but they never reach the speed of light, theoretically. Tachyons are linked to relativity, raising questions about how they would interact with gravity and the curvature of space-time. If tachyons exist, they could potentially allow for faster-than-light communication, revolutionizing space exploration. The tachyonic anti-telephone is a thought experiment where tachyons could enable communication backward in time. Tachyonic matter is unstable and could have exotic properties, potentially creating phenomena like time loops or paradoxes. Despite extensive searches in particle physics, no evidence of tachyons has been found, but their theoretical existence still sparks curiosity. The tachyon models show potential faster-than-light interactions.
Could they bridge to other dimensions?
Exactly. These patterns suggest new realities. If proven real, tachyons could fundamentally alter our understanding of physics, challenging everything we know about space, time, and energy. For now, tachyons remain a tantalizing mystery, but the quest for their discovery drives us to reach beyond the known and explore the unimaginable. Tachyonic fields are theorized to play a fundamental role in quantum mechanics, potentially altering the way particles interact at a quantum level. In string theory, tachyons are sometimes viewed as indicators of instability, helping science explore extra dimensions beyond our own. Could tachyons be linked to dark energy, the mysterious force driving the accelerated expansion of the universe? Some theories suggest a connection. If tachyons exist, they might offer new insights into black hole physics, where extreme gravitational forces could affect their behavior. The concept of tachyons challenges the arrow of time, suggesting that time may not be a one-way street after all. Tachyons could potentially be the key to understanding the multiverse, allowing access to parallel universes where different laws of physics apply. If harnessed, tachyons could revolutionize technology, from energy production to transportation, enabling futuristic advancements. The possibility of time travel is often linked to tachyons, where their faster-than-light travel could offer a way to navigate through time itself. The search for tachyons continues in particle accelerators around the world, but despite extensive research, direct evidence remains elusive. Tachyons remain a theoretical enigma, but their study encourages us to dream beyond the limitations of our current understanding, reaching into the unknown realms of physics. A tachyon condensate represents a vacuum state where tachyons play a pivotal role, marking the transition from instability to stability in quantum fields. Tachyon decay is theorized to result in the emission of high-energy particles, offering insight into how exotic particles might interact within fundamental forces. Tachyons might possess negative mass, an idea that defies Newton's laws and could lead to the creation of anti-gravitational phenomena. Tachyons could have been instrumental in the early universe, potentially affecting the distribution of energy and matter during the Big Bang and the subsequent evolution of galaxies. The discovery of tachyons would force us to reconsider our place in the universe, fundamentally changing how we think about time, space, and causality.
Could tachyons alter our perception of reality? If we could harness them, we might perceive the world in ways that challenge our conventional senses.
Tachyons challenge the concept of linear. Some even speculate that they could play a role where the boundaries of past, present, and future dissolve. As scientists continue their search for tachyons, the journey ahead holds the promise of unlocking mysteries that could change our understanding of the universe. Despite our advancements, many questions about tachyons remain unanswered, leaving an open path for future generations to explore. The study of tachyons represents the boundary of what we know, a field that encourages us to push the limits of scientific inquiry and imagination. Tachyons remind us that there's always more to discover. In the infinite expanse of space and time. Could tachyons be linked to quantum entanglement, allowing faster-than-light communication between entangled particles, regardless of distance? The discovery of tachyons could be the key to a unified theory of physics, merging quantum relativity and explaining the forces that govern the universe. Tachyons challenge our fundamental understanding of reality. If they exist, they may hold the secret to unlocking the fluid, multidimensional nature of our universe. If tachyons enable faster-than-light travel, they could alter the concept of free will, raising philosophical questions about fate, causality, and the choices we make. Supercomputers will play a pivotal role in simulating tachyons and their interactions, helping scientists understand their behavior in controlled environments before any real-world discovery.
Tachyon research will require
Trails match our models, like energy trick hypothesis, initiating now. Harnessing the power of tachyons could revolutionize space travel, allowing humanity to reach distant stars and galaxies in a fraction of the time. Tachyons could unlock new, clean sources of energy, providing power for entire cities without the limitations of traditional energy resources.
The potential for discovery in tachyon research is limitless, opening doors to realms of physics and space that we have yet to imagine.
Tachyons push the boundaries of science, inviting us to explore the very edge of our understanding, where the rules of physics bend and transform.
As we venture further into the unknown, the discovery of tachyons could mark the beginning of a new era in physics.
The search for tachyons is far from over. As technology advances, the possibility of their discovery becomes more real with each passing day. Humanity's quest for knowledge continues to push us toward the unknown, with tachyons offering the promise of uncharted territories waiting to be explored. In the infinite vastness of space, the quest for tachyons continues to inspire, guiding us toward new frontiers in the realm of theoretical physics. Could tachyons be the missing link to understanding dark matter? their behavior may reveal the nature of this invisible force that makes up most of the universe. Tachyons could potentially interact with gravitational waves, offering new insights into the fabric of spacetime and the mysterious phenomena of black holes. In the future of quantum computing, tachyons could play a crucial role in exponentially increasing computing capabilities. If tachyons exist, they could potentially create time loops, where actions taken in the present might affect. Tachyons could challenge the laws of thermodynamics, particularly the concept of entropy. Could they reverse or influence the flow of energy in ways we don't yet understand? The study of tachyons may help scientists understand antimatter better, opening up new possibilities for energy production and theoretical applications in propulsion systems. Tachyons might have played a role in the Big Bang, shaping the early universe by influencing the distribution of energy and matter at a quantum level. Tachyons could significantly impact cosmology, providing answers to questions about the origin, evolution, and eventual fate of the universe itself. Tachyons might offer a glimpse into the multidimensional nature of the universe, where particles exist in multiple states across alternate realities. A tachyonic field could be a fundamental force in the universe, affecting all forms of matter and energy, and perhaps explaining the mysterious forces at play in the cosmos.
Can you hear me?
Yes, the signal is clear.
What is your world like?
It is beautiful.
Could tachyons hold the key to understanding consciousness? If they influence quantum processes in the brain, they might explain how our minds perceive the world around us.
The search for the first tachyon is one of the most exciting frontiers in modern physics. Missions may soon be launched to.
While theoretical physics presents the concept of tachyons, experimental physics is still searching for the empirical evidence to prove their existence. Regardless of whether tachyons are ever found, their study will leave a lasting legacy, driving future advances.
The universe is full of mysteries, and tachyons are just one of the many unknowns. As scientists,
Tachyons may interact with the fabric of spacetime itself, distorting it in ways that could reveal new properties of the cosmos we have yet to understand. In quantum field theory, tachyons are linked to instability, suggesting that they might trigger new kinds of phase transitions or quantum fluctuations. If tachyons exist, they could be connected to the quantum nature of gravity, offering insights into how gravity behaves at the smallest scales. Tachyons might hold the key to creating or interacting with alternate realities, allowing for the exploration of entirely new worlds. If tachyons possess negative mass, they could provide the basis for anti-gravity technologies, potentially enabling new forms of transportation and propulsion. Theoretical interactions between tachyons and regular matter could create exotic forms of matter with unusual properties, challenging our understanding of the physical world. Tachyons could be the missing piece in the search for a grand unified theory, potentially linking the four fundamental forces of nature. The discovery of tachyons could lead to a complete rewrite of modern physics, forcing scientists to reconsider everything from the nature of space to the fundamentals of time and energy. Tachyons could pave the way for the next generation of quantum AI, enabling machines to solve complex problems at speeds far beyond current computational capability. With tachyon-based propulsion, space exploration could reach unprecedented speeds, allowing humanity. The existence of tachyons might make time travel a reality, allowing humanity to move freely between different points in time, reshaping history as we know it.